See anyone else out there? Oh, there is someone else out there. You can see anyone else out there? All right. So thanks for your help the other day. All right, so page 121, again, this will be something that we'll want to use for our review. Well, hello. We'll want to use as one of our review pages, definitely. I would definitely say that the 121, 122, 123, 124, I'll let you use those two sheets on the test. That'll be 2-day test on Friday and Monday. All right. Problem number 1. Says a true recent Danish study focused on mothers who take fish oil supplements during pregnancy and whether it reduces the risk of asthma in their children. Hey friends, people take all sorts of supplements, right? Perhaps you do, perhaps your parents do, grandparents. I know when you see some of the supplements that people are taking, it seems like it could be a meal in itself. It's like, you're taking that entire cup of stuff? Oh yeah, this pill's for this and this. Okay. All right. So state the null and the alternative. All right. So our null hypothesis, fish oil has no effect on asthma. If I could spell asthma, that'd be good. In children. And then we're on page 121, my friends. Yeah. And then our alternative, 121 when you get there. Our alternative is fish oil reduces asthma in kids. One tail or two? One tail or two? It's one. Why is that? Because reduce is a direction, right? So that right there makes it a one-tail scenario. And again, most of the time when you're doing statistics, you would want to do a one-tail. You don't want to do a two-tail. So again, for those of you who just came in, we will have a 2-day test Friday and then Monday. This page, and then I realize tomorrow is a day off. Wednesday's a day off. Thursday, we will do the other thing, but I hope to get through the front and back of this. And whatever we don't get done today, we will continue on Thursday, and then you would use these 2 pages on the test. So page 121 is the page we're on right now. And this is definitely good stuff that you might want to write down so you could use these pages on the test on Friday and Monday. All right. The study was performed in approximately 700 Danish women. Are 3 assumptions met? What are the consequences on not failing the assumptions? Let's see. Well, if you had 700 people, I'd say you're jumping right away saying this. We don't have percents. We don't have any of the percents that are given, so we don't do, so no on the n times p is greater than or equal to 10, and the n times 1 minus p is greater than or equal to 10. But this is a large enough. But where is the word? Where is the random? Okay, we're on 121. This would be good stuff to be writing down for the test on Friday and Monday. Cool. So I love the 700 people they say. It's great, but it doesn't say that we have a, doesn't say it was a random selection. It doesn't say anything about that. So though we have nice high numbers, might not be the best. Okay? All right. Then number 3. If this was a type 1 error, Oh my gosh, I can't write. This was a type 1 error. This would say we find strong evidence that fish oil improves asthma. But it really doesn't. So the consequence in this situation be if we found that there was strong evidence that it improves asthma in kids, but it really doesn't, basically someone's just wasting money. Does not. Okay. Cool. Give you a couple minutes about a minute to get whatever copy down you need to copy down. I guess I could take attendance at this point. There's more of you here than there is not. Is there any questions on any of what we just discussed? Seems pretty straightforward, I hope. Hey, good to see you. We're on page 121. It would be good to write down any of this stuff for tests. That'll be Friday and Monday, 2-part. So the tests, while you guys are writing stuff down, just kind of getting caught up, the test will be, each day will be a front back of multiple choice on each day, and then there'll be a front back of a small problem, something like this type of thing. Deal? Gabby not here? Oh, thank you for letting me know. All right. So no. Oh. Oh, did she show up? Was she just here just now? No. Oh, okay. But was sent it. Okay, they'll mark her. They'll give her the good news. All right, friends. Do you need any more time, or can I move off this page? Good. All right, I can just move down so we can move back up if we need to. All right. Number 4. What would a type 2 error be in this situation? We haven't proven anything. We're just saying, hey, this took place. So type 2 error would we fail to find evidence about this fish oil. And asthma, when it really does. Oops. All right. So then number 5 and 6 actually go along with 3 and 4. So type 1 error, if you found strong evidence fish oil improves asthma, but it really does not, that just means you're taking fish oil, and I don't think there's any harmful effects from taking fish oil. But a type 2 error might be bad because you failed to find evidence that fish oil and asthma have some sort of relation when it actually does help out. So it's one of those where, hey, you got to be looking at type 1 and type 2 errors, and you know what's the better and the worst. We're on page 121, fellas. So number 5 basically just says, explain the consequence of a type 1 error. So take fish oil, for no reason. tell you that the supplements that people take for all these gamut of reasons, there's a lot of people that are wasting a lot of money. But if it makes them feel better about doing it, well, I don't know what the harm is. So they're taking fish oil and doesn't have any goods or bad effects for the asthma. And then number 6, and then I want to label this, that this was a type 1 consequence. This is a type 2 consequence. All right, so number 6, explain making a type 2. So you missed, hey, the chance to reduce asthma. We're on 121, 122. Okay. This will be for the quiz on, or the test on Monday and Tuesday of next, or excuse me, Friday this week, Monday of next week. Make sense? So these would be 2 good pages. All right. So can everyone see that how number 5 doesn't really seem, I mean, other than your wallet is getting hit if it has no effect, but type 2, your wallet might be getting hit because you might be paying medical bills for your kid that you could have maybe reduced asthma for. But again, we don't know if there's any truth to this or not. But I think you guys especially, well, the nice thing is you guys have been brought up with the streaming era. So I don't know how many commercials you've actually been subjected to. But me as a kid, and before VCRs, that was how you used to be able to record, and you could fast forward the commercials after you recorded it. Saw way too many commercials. All right. Number 7. Still on page 121. Assume our study rejects the null hypothesis. What conclusion is appropriate in this context? Am I still all right? Yep. Okay. All right, so for number 7, assume that we reject the null. So we reject this. So if you remember, our null is up above, but we had said fish oil has no effect. On asthma. Okay, so if I reject this, what does that mean? Well, it means that if this is rejected, this means we found strong evidence, F-O-U-N-D, strong evidence that fish oil works. Okay. And number 8 is going to stick out to me, so highlight this however you need to on your page. Assume that the alpha was 0.10. Okay, so they're just giving us stuff as we go through. Assume alpha is 0.10 and we rejected the null. What is the probability of a type 1 and type 2 error? Okay, so we had an alpha of 0.10, we reject the null. Okay, so type 1 error means we have a 10% chance. Type 2 is a 0% chance. Now, why does a type 1 error have an advantage in this case, whereas a type 2 error doesn't? The answer is the type 1 error from above is that we're taking fish oil for no reason. Okay, we if we're rejecting the null when it was actually true, that's the type 1 error. Rejecting the null is not going to give you a type 2 error at all. Okay? So that's why it's that. And then number 9, last one from that page. I think this is all kind of bringing stuff together, I hope. So again, they're saying alpha is 0.10. So alpha 0.10 is considered a little high for this medical study. What advantage and disadvantage of using a higher alpha level? So if we increase alpha, it becomes easier to reject the null. Okay. It increases the chance of a type 1 error. Okay? So, my friends, that's page 121. That's a good review. I would say that would be a fantastic page. That would be very helpful this coming Friday and the following Monday. And I will have it recorded. You feel okay? All right. Can I get through 122? You have faith in me? Happy for the faith. All right. So on page 122, again, these two, page 121, 122, if you missed part of 121, watch the first part of the video and get it filled out because it'll be so helpful come the 2-day test we have on Friday and then Monday this week. All right. So this says the percentage of people who file their tax returns was 81%, or on time was 81%, according to the most recent census. A sample of 400 tax returns was selected. 308 were filed on time. Okay. So we have 81 filed on time as an overall. And then they told us 308 out of 400, some sample, took place. All right, so let's 308 divided by 400. So our sample showed 77%. Okay? All right, so we haven't done any of the null or anything yet, so I was just writing this down. So number 10 says, create the null. Percent filed taxes, or something like taxes on time or something like that, is 81%. Our alternative, so percent filed, I don't know, on time, so percent filed on time is not 81%. Not. All right. On time. Could something be turned in early? Yeah, I mean, I could, it'd be kind of weird, but I could submit next year's taxes already. I don't know why I would, but I could. So on time, one or two tail? Two tail, good. So the on time's not directional. This will be a two-tail scenario. Okay. All right. So that's just number 11. Okay, so it's two-tailed because the word on time, it's not really directional. Something could come in early, some could come in late, something like that. So that's number 11. Number 12, this is going to be a one proportion z-test where we'll have to find the standard error. Okay. So number 13, our standard error that they're asking us for. Let's see, calculate standard error 13. So standard error is going to be, bless you, percent, 1 minus percent over n. So we have 0.81 minus 1.81. And they had a random selection of 400. So if we do that math, it comes out to roughly 0.02. Okay, so this is our standard error. Our standard error is going to go in place of the standard deviation, in which we can do our normal curve. Oops, no, I don't want to go on. Just want to expand. So 14. All right, they had said 81%. I'm going to change my standard error to 2%, okay, rather than 0.02. And so that's going to give me 83% this way, 85%, 87%, 79%, 77%, and 75%. All right, and they're saying we found 77%. Okay, so 77%, so we're like going down here. So that's 1, 2 standard deviations, but I also have to go this way. Okay, because it's two-tail, shade equal region. Okay, give me a sec. All right, so calculate the p-value. So friends, how do we calculate the p-value? What do we use? Desmos. Okay, so we got to use Desmos. And whatever our p-value is, we have to multiply by 2 because it's a two-tailed test. And I'm trying to give you as much opportunity so you see these things. If it was just a one-tail, we would have to just take the p-value. All right, so our friends, the Desmos family, is stepping up for us again. We like these folks. Graphic calculator. So being that we're using 400, it should be normal distribution because it's a higher thing. We're going to do 81%, and we're doing 2%. Okay, if you made this as decimals, you'd go 0.81 and 0.02, but it doesn't really matter which one you'd use. And then we have to just find it one way. So they had found 77 or lower. So if I went 77 or lower, we get down there. So we get 0.02, and we have to double that. So I'm going to go 0.02 times 2. So 0.04, which I know we could have done. All right, so is everyone good with Desmos? Why are we doubling it? Because it's two-tailed, thank you. So we get a p-value. Once it's doubled, we get 0.02, and we multiply that times 2, so we get 0.04. All right, explain what the p-value means in the context of this problem. All right, we have a 4% chance that the 77% produced higher sample could happen if our null is true. Now, we can't really test the null because we didn't have any alpha. I mean, we could have done with 0.05. So we're less than 0.05, but technically the 0.05 you should change to 0.10 because you had to double the p-value. So 0.1 is greater than 0.04 or 0.04 is less than 0.1. So we could do that. And then explain what happens to the standard error if we select a larger sample size. In theory, would a sample size make it more or less likely to reject the null? So the standard error goes down. So number 17, if we increase n, if this is increased, standard error is smaller, and more likely to reject the null. Okay, so my friends, that page 122 and 120 or 121, 122 would be extremely helpful when. Oh wait, did I mess up? Explain what happens here. My questions matched up, right? Okay, good. Sometimes when I have my last year's notes and I don't realize the book changed, and then all of a sudden it's like, hey, why is number 16 different than yours? Because I made a mistake. So if you